Hello, my name is Rob Reynolds. Welcome to College Algebra Section 3.6. We're going to be taking a look at some word problems today, oftentimes mathematical models. So we're going to be analyzing some functions. Basically, you're going to be writing the equation and then writing an equation, and then plugging one function into another function. For example, we know this is the quadratic function. This gets shifted, vertical shift 1 unit down. What if we want to find this red distance in here between the origin and any point on the function? We'll call that D. And so I'm going to start with a formula. We know the distance is the square root of x minus x, quantity squared plus 1. So here's just the distance formula. But it's interesting, I've got some x's and some y's that are some zeros, so I'm going to plug those in. So if I say x minus 0, quantity squared, I just get x squared plus y squared. And it's really interesting, but I know that the y term is x squared minus 1. So if I square both sides, I can do anything I want to an equation as long as I do both sides. I'll get a nice definition for y squared. And this is what I was talking about. You get two equations. So I kind of have one equation kind of going up here, which is the equation of the parabola, and then I have another equation, which is that distance formula, and I'm going to solve for one equation and plug it into the other. Let me show you what I mean. If I have this, let's FOIL this term out. So this is, I can't distribute, but I could square the first, twice the product, square the last, and then I'm going to plug that value in for y squared. So continuing on here, I'll get a new definition. The square root of x squared plus x to the fourth minus 2x squared plus 1. And it looks like I can combine some like terms here. I've got a negative 2x squared and an x squared. And I'll put the x to the fourth term first. So x to the fourth minus x squared plus 1. So there's the distance for any x value in terms of x. So let's answer a couple of the questions. Express the distance d from P from the origin as a function of x. So that's what we have. We have the distance as a function of x, and that's what that means. There's that distance in terms of x. That's why I could not leave y in the problem. It has to be a function of x. So there's answer A. Answer B is talking about what is the distance if x is 0. Well, it becomes really simple. All I do is plug in d sub 0. So let's do it. 0 to the fourth minus, that's the square root of 1, which is just 1. Then for part C, it's asking what's the distance if I let it be 1. Oh, and then the next one is the square root of 2 over 2. That's great. So d sub 1 is 1 to the fourth minus 1 plus 1, and that's also 1. So that's kind of interesting. So if the x value is 0, it's 1, and if the x value is 1, see, if the x value is 0, then y is negative 1, and that distance is 1. That kind of makes sense. And if x is 1, so really it's just that distance and that distance that we found. That wasn't even really that interesting. But the formula is working. The last part says, what did it say? The square root of 2 divided by 2. That's going to be a mathematical nightmare. Yep, the square root of 2 divided by 2. Let's see if we can crank this out. I'm going to do this square root of 2 over 2 to the fourth minus the square root of 2 over 2 squared, and then lastly I'll add 1. So let's talk about this guy right in here. The square root of 2 over 2 divided by, well, I know, let's just worry about the numerator first of all. If I just look at the numerator, it says the square root of 2 to the fourth, which is the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. So this is 2. This is 2 more. Hey, that's not bad. That's a 4 in the numerator divided by 2 to the fourth, which is 16. I can reduce that in a moment, but no need. I'll just take my calculator and crunch it. Minus this is the square root of 2 squared is a 2 fourths plus 1. So at this point in time, since it doesn't say I can't use my calculator, I'll probably just crunch it in my calculator. So my calculator says 0.75. If I hit math, enter, enter, that'll convert it to a nice fraction, which I'm probably more interested in. So 3/4. The reason why I like the 3/4 is that's the square root of 3 over the square root of 4, which we know is the square root of 3 over 2. Oof, that was not easy, but that's the answer, I believe, to part D. And then part E says what? Use your calculator, find the minimum. Find the local minimum, but don't find the minimum of this function. No, it's saying find the minimum of D. So what was that D function? Here it is. So I'm going to use my graphing calculator. I'm going to try to graph that in my calculator and find the minimum. So under my y equals, I'm going to do the square root. I always hit zoom 6 the first time I graph. Probably won't see what I want to see at zoom 6. Find the minimum. Well, closest to 0. So I kind of want to zoom in here a little bit. Let's see, do I have the right function? Square root of x to the 4th minus x squared plus 1. Yeah. Okay. I'm going to hit zoom to enter. Maybe I'll get a little bit better picture. Again, I'm interested in what's going on, like in this area, right here. So I think I'm gonna just zoom in again. Zoom to enter. It's changing my window. Hey, I think I see it kind of going down. I need to see a little bit further to the right. So that's my x max. So, oh no, should I change it to a 2? Looking a little bit further to the right. Okay, I think aha! I got a nice minimum now. Second calculate, let's go find the minimum. It's kind of just a guessing game, guys. So I'm going to try 1. Ugh, that's not good. I got to try 0. So second calculate, I'm going to go for the minimum. My left guess will be 0. The right guess will be 2. Yeah, and then I'll guess a 1. So that was my guess left, guess right, guess on. So there's my final solution. It looks like the x value is 0.707. That's not bad. So I'll capture that. Save that. All right. So there's my minimum. And let's see if the author agrees. Yep, there it is. Great. 707. Let's try another problem. Again, there's a function, and then they ask for the area of well, I know the area function. It's length times width, but it's also base times height. But in this case, it's also the x value times the y value. So this is the base, this is the height. So it's sum over x and up y. So I'll say xy. And I have a nice value of y, which I'm going to plug in, because it says express the area as a function of x. So here comes the area as a function. Oh, this one's easier. The y value is what? 25 minus x squared. So my function in terms of x maybe would be 25x minus x cubed. So there's the area as a function of x, which they're probably going to make me graph and find the max or the min. In this case, I think I want to maximize area. So it says, what's the domain of this thing? Again, it doesn't make sense to have negative values. It looks like it's going to be between 0 and 5 is the domain. Graph the function, which I guess we're going to try to do that now, and then find the largest area. Of course, we recognize that as the max. So let's graph this thing. And see if we can't find the maximum this time. I'm going to zoom 6. Again, I'm not expecting good things when I see zoom 6 because that just gives me a standard 10 by 10, but at least I start somewhere under my window. And I can see that I need to see a lot higher, so I'm going to go under my window and change that Y max. I don't know, I'll guess 100. It might be even 1,000, but I'll start at 100. Now that's not bad. I'm going to find the max. Second, calculate. I'm going to find number 4, the maximum this time. My guess left will be 0. My guess right will be 8, just because I think it goes out to 10. I'm going to guess a 5. So that's my guess left, guess right. It looks like 2.89. That's not bad. Does the author have... Yep, there's the domain between 0 and 5. And there it is. 2.89 is the maximum area. Oh, and the maximum, oh, this is the x value to give us a maximum area of 48.11, which I think that's what I, yep, 48.11. Good, good, good. All right, so that's the second example. The third example that I have is a little bit more complicated. Looks like I have a playpen here, 3 by 6, which gives me 18 square feet on the bottom, and then a height that looks like 3 as well, although it's not labeled very well, but I'm assuming that's a 3 as well. But I've got 18 square feet because this is a 3 by 6 by 3 by 6, so I've got 18 square feet on the bottom. The neat thing about this playpen is it's got a hinge right here, and if I pull that hinge out, I'll get a new playpen with even more area than the original playpen. So the question is, what's the maximum area if should I pull that out to give me more space for the child to run around with? So the area, the whole area that I'm going to look at, I believe, is I've got this rectangle thing going on, and then I have a red triangle. So I think the area of this thing is going to be the area of the rectangle plus the area of the triangle, because it says express the area. I know this has volume, so we don't really need to worry. That's probably why they didn't give us the height. So I can ignore this, because that would be talking about volume. And they just keep talking about area. So we're just talking about maximum area here. So I'm going to pull out this red triangle out here, where this distance is x, along here is my x distance. I know that it's an isosceles triangle because those two sides are 3. That means that these two angles are congruent. So that's what forms this isosceles. If the two sides are congruent, then the angles are congruent. If I drop the hypotenuse, I get a right triangle in here, and this distance will be half of the distance x. So I have a nice right triangle, which I think I can now do a squared plus b squared equals c squared to find this, I'll call it h side. And for sake of time, I think the author's already worked this out. So there it is. There's that a squared plus b squared, the Pythagorean theorem, equals c squared. But notice they've replaced that with the h squared. We decided that this length was b, so we're doing what? This side, h squared plus x over 2 squared is equal to 9. And that's what they have over here. It's equal to 9. There's their 9. And they solve for h, which is this 1/2 the square root of 36 minus x squared. But that's not the answer. That's just the height of the triangle. So we need to go back and add the area of the rectangle to the area of the triangle. So we haven't even really found area of the triangle yet. But remember, the area of the triangle is 1/2 the base times that height that we found. And the base is x, the base of the triangle, and the height is this terrible, well, there it is right there in yellow, the 1/2. And we know that the area of the rectangle is just 3x, because what? It's 3 by some x distance, which has yet to be determined. So we'll just keep it 3x. So there's the area. Check. now the area is expressed in terms of x. So then it says find the area when x is 5, and you could just evaluate that either on your calculator or by hand. There's the domain of this thing. You can look at the graph of it, but again, the domain of this thing says we've got to make sure that this guy, when you talk about domain, you want to watch out for dividing by 0 and taking the square roots of negatives. So the only thing that's going to cause havoc in this one is when that 36 minus x, that has to be greater than or equal to 0 so that it remains positive, because you want to take the square roots of only positive. So that's why they're setting 36 minus x squared greater than 0 means, yeah, remain positive with this problem. So again, you can graph this function and you can find the maximum. Like we did before, it's a little bit more complicated. Practice this on your calculator. This is the maximum area, and then this is what you should set the height as. This is what you should set x as, that length. And you could solve for the height as well by plugging in that x value. So I hope that's helpful. Please email me with your questions. Thanks.